Hi guys, our final unit for the year is called Indices and Logarithms, and in this unit we're going to learn how to graph functions like this, where the independent variable is a power rather than being down here, and we're going to learn how to solve problems like this without using trial and error on your calculator. Okay, but before we can do any of that, we're going to have a quick review of all of the index laws. So let's start off with the most basic. So a to the power of 0, anything raised to the power of 0 is simply equal to 1, like so. So if I have 2 to the power of 0, then I can say it's equal to 1 without doing anything further. Easy as that. Second one is when I have two numbers multiplied together. Now I should say, just to remind you, that this number here, A, is called the base, and M and N are the indices, sometimes called the powers, sometimes called the exponents. So if you see those words, it all kind of means the same thing. But we've got a same base of A, we've got indices here, and so the rule is quite simply a to the power of M times a to the power of N is equal to a to the power of m plus n. So if I have, say, for example, 2 squared, which is 4, and multiply it by 2 to the power of 3, which is 8, I get 2 to the power of 5. So 8 times 4 is 32, and 2 to the power of 5 is 32. Okay, next one. A to the power of m over a to the power of n. Now remember, in algebra we don't write divisions, but this is effectively a division. A to the power of m divided by a to the power of n. So when we have a division with the same base, different powers, that's equal to a to the power of m minus n. So if I have 2 to the power of 5 over 2 to the power of 3, that's equal to 2 to the power of 5 minus 3, which is 2 squared, which is 4. Just like that. Next one. A to the power of m all to the power of n will be the way to say this one. So the way we solve that, well, the way that works is that we multiply the powers together, or the indices together. So that's a to the power of m times n, which we would simply write as a to the power of mn, like so. So if I have 3 squared and cube the result, that would be the same as 3 to the power of 2 times 3, which is equal to 3 to the power of 6. Don't know what that is, but a big number. Next one. A to the power of 1 on n. So this is a fractional index. When we use these in our calculus unit, if you remember. So hopefully this is just another reminder from that. So a to the power of 1 on n is equal to the nth root of a. Note that is not n times square root a, it's the nth root of a. So if I have, for example, 8 to the power of a third, that would be the third root of 8. In other words, what number do I multiply by itself 3 times over to get 8? So that would be 2. So 8 to the power of a third is equal to 2. So when we have a to the power of m over n, then that is equal to the nth root of a to the power of m, like so. So the nth root of a to the power of m. Now this might give us some opportunities for simplification. So if I have, say, 2 to the power of 4/5, then that's simply the 5th root of 2 to the power of 4, which can be written as the 5th root of 16. So there's not much we can do there. But if we have an improper fraction, so if we have 2 to the power of, let's just go 5/4 instead, 2 to the power of 5 on 4, well, that's the 4th root of 2 to the power of 5. But what we can do then is we can say, well, that's actually the 4th root of 2 to the power of 4 times 2. Yeah, so remembering that there's actually a power of 1 there which we don't write in, but if we did, we would then have 4 plus 1 equals 5, but we don't tend to write in that power of 1 normally. But what that means we can do is we can say for this bit here, the fourth root of 2 to the power of 4, that's just 2, right? Because the fourth root is the opposite of raising to a power of 4. So that just gives us 2. And so that's equal to 2 fourth root 2. Okay, moving on. This one is a to the power of negative n. Now when we have a negative index, it affects the number like so. A to the power of negative n is equal to 1 on a to the power of positive n. And that works for whatever value n is. N could be a fraction, n could be a whole number, positive or negative. It works, whatever n is. But looking at it in terms of a practical example, if I have 3 to the power of negative 2, I can't do much with that, but I can go 3 to the power of negative 2 is 1 on 3 squared, which equals 1 on 9. Now, with negative indices, you'll often find in the question, it might say something like, simplify this expression and leave with positive indices. That's kind of what it's telling you to do, is to work out if you've got a negative index here, make sure you do this. Now, I kind of call this sinking or floating, because if the negative index is down here, then we do the reverse operation, and I'll show you that on the next page. So with 1 on a to the negative n, it's the reverse. It's equal to a to the power of n. So I kind of call it sinking and floating. So if you've got a negative index on the top, we can sink that down to the bottom, so it becomes 1 on a to the positive n. If I've got a to the power of negative n on the bottom, I can float that up to the top. So it changes where it is, as it were, in terms of a numerator and denominator. Okay, so if I end up with something like 1 on 3 to the power of negative 2, then that's the same as 3 squared, which is equal to 9. Now with all of these rules, I can go through sort of longer examples to demonstrate why these rules work. You should have done them in grade 9 methods, so I'm not going to spend any time on it at all really, other than say you need to learn these rules. So all of these rules that I've gone through, it would be really handy to put them into your summary book as a single list, so that you can sort of refer to them and use them. That's going to be really important to be on top of those things, because if you're not, then when it comes to doing more difficult stuff with indices and logarithms as well a bit later on, it's going to be a bit too difficult to sort of keep all those concepts in your head. So try and get on top of these concepts as best as you can. Here's an example problem that you might be required to simplify. So, look, there's a few ways you can do it. There's no real brilliant way of doing it. After a while, you get used to working out the shortcuts to simplifying this without too much trouble. But let me just show you how I'd solve this using our basic index laws. So first of all, you can only simplify when it's a product on the top and a product on the bottom. So if there was a plus in between here, I couldn't simplify things as I go along. So that's critical point number 1. You can only cancel down with multiplications and divisions. You can't cancel down across additions or subtractions. Okay, keeping that in mind, look, there's probably easier and faster ways of doing this, like for example a cubed and a cubed surely will cancel out, and it does. But let me show you what it looks like if I just applied some of the basic index law rules. So the index law about division says that if it has the same base, then I subtract the indices away from each other. It does have to be the same base. If it's not the same base, then I can't do much with them. But I can in this case, because I can go that is equal to a to the power of 3, that's the top one there, minus 3, and the minus 3 comes from the fact that I'm dividing and there's a 3 on the bottom there as well. And then my other term is a b. So then I've got b to the power of 2. That comes from the top here. Minus 5. So the minus 5 comes from divided by and then the 5 down the bottom. Okay, so having done that, a to the power of 3 minus 3 is a to the power of 0. B to the power of 2 minus 5 is b to the power of negative 3. And because a to the power of 0 is equal to 1, that just means I've got b to the power of negative 3. I hope I can do that without sort of spelling out that power of 0 thing. Now that's okay, that's your answer, b to the power of negative 3. But if your problem says express with positive indices, then you'd go one step further and say, well, to make that b to the power of negative 3 positive, I'd sink it down to the bottom like so. So it'll be 1 over b to the power of 3. Okay, so that's your basic index laws. Make sure that you know them and can apply them. In class, I know that we've had a look at the textbook and seen some exercises which get you to practice all of those, so I strongly encourage you to use those as practice. In the next video, we will have a look at some basic indicial equations, and that will round off our learning for this week. Thanks very much.